Hi, now continuation numerical from the oscillation. A block P of mass m is placed on a frictionless horizontal surface. Another block Q of same mass is kept on P and connected to the wall with the help of spring constant K as shown in the figure. Mu s is the coefficient of friction between P and Q. Blocks move together, perform simple harmonic motion of amplitude A. The maximum value of frictional force between P and Q. What is our question? Maximum value of frictional force. So, our question is F maximum, which is equal to question mark. According to the question here, K is the spring constant. This is the P block and this is the Q block, and Q block is contact with the P and there is a frictional force between them, that is mu s is the coefficient of static friction, but there is no frictional force between the P and the floor, that is smooth floor. So this is the wall, this is the floor. Okay, so due to the small displacement along the horizontal direction, what happened? The spring get elongated at a displacement x. Okay, so due to this, the system has an acceleration a. Okay, so there is a frictional force. So now this is the frictional force, and here also frictional force acting. Due to this frictional force, P block move along with the Q block, and here this frictional force on Q which oppose the motion of the block Q. See, now due to the acceleration of this system, there is a pseudo force acting. That pseudo force is taken as here capital F. Okay, so pseudo force is opposite to the acceleration of the system. Now continuation, here angular velocity omega, which is equal to k by m, is the basic formula from the simple harmonic motion that is given in the question also, simple harmonic motion. See now, okay, omega square, which is equal to k divided by, here only single mass is there, but in the question given as two masses of equal mass, so then m plus m, so omega square which is equal to k divided by 2m. So this is taken as equation number 1. Okay, so next point is, that is magnitude of maximum acceleration. So maximum acceleration, here writing maximum acceleration, so that is A max, which is equal to A omega square. See now, so A max, here negative sign I am not writing, reason is magnitude of maximum acceleration. This value is replacing here, we will get A max, which is equal to A into k divided by 2m. This is taken as equation number 2. Okay, what is our question? Maximum, okay, maximum frictional force is asking from the question. Okay, so for that we have to write initially here there is a pseudo force F is equal to ma. Okay, this pseudo force is equal to the frictional force, so F which is equal to ma maximum, that is frictional force is maximum. So here this equation is replacing here, so we will get here F max, which is equal to m into A max value is, okay, ak divided by 2m, mm is get cancelled. Finally we got F maximum frictional force, which is equal to ak divided by 2 is the answer for the given question.